Alright guys, so this is my first video here on my new computer, so I'm hoping maybe my voice is a little clearer, and my computer actually lets me write. So we're starting this chapter on energy. So before we get started, I want you to stop for a second and think about what energy is. So what do you think energy is? Before you move on to get full credit for your notes, I want you to write next to somewhere towards the top of the title and write down what you think energy is and what ways you think that you use energy. I mean, we use energy in lots of different ways, so take some time right now, write down some kind of general definition you think, and then ways that you use energy, and that's to get full points for your notes. There's not a place to write down these words, but write it out somewhere at the top or to the side or something. So hopefully you've got something written down, or if not, pause this. Because right now I'm going to give you the actual definition of energy. And the actual definition of energy is the ability to do work. So I'm going to guess that most of you probably didn't quite have these words. But if something has the ability to work, that means it has energy. Each time that work is done, energy is given by one object to another that allows it to do work. Remember, we've talked about the law of conservation of energy. Energy just can't just go away, and it can't just appear out of nowhere, but it can be transferred from one thing to another. So if you are doing work on a car by pushing the car and it's moving, you're transferring your energy to that car. And energy is measured in joules. So just like work, energy is also measured in joules. Just one example of many, many examples of energy. A tennis player, when they have a racket, they can do work on the racket because he or she has energy. They have the ability to do work on the racket. They have the ability to swing the racket, which is doing work, moving it in the direction of the force. When that person does work on the racket, it's going to gain ability to do work on the ball, because now the energy from that tennis player's hand and arm and whatever, the muscles that are moving it is now being transferred to that racket and giving it the energy to hit the ball. And then the same kind of transfer happens from racket to ball. So then once the ball has work done on it, now it has the ability to do work on another object. Let's say, if it hit something and knocked it over, it had the ability to do work on that, and so on and so forth. The energy just keeps getting transferred and converted, and we're going to talk more about that conservation and energy conversions as we get further into this chapter. So kinetic energy is our first type of specific energy we're going to talk about. We're going to probably talk about 7 or 8 different types here, but this is our first. And kinetic energy is the energy of motion. If you've ever heard of kinetics, that is all about the study of motion. So anything that is moving has kinetic energy. No matter how slow it is moving, if it's moving, it has kinetic energy. We constantly have kinetic energy because our body, there's always stuff moving in our body. Even if we're sitting still, within our body, inside with our organs and stuff, there's some kind of kinetic energy happening. If an object has kinetic energy, it can do work because it has the ability, it has energy and has the ability to work on other objects. First equation of this chapter, and we have a few different equations for us to look at, is the kinetic energy equation. The kinetic energy equation is mass times volume or times velocity squared, all divided by 2. So I'm going to write that out, maybe, if it lets me here. Alright, maybe it's still not going to let me for some reason. Okay, no big deal. But mass times velocity squared, all divided by 2. So basically, the larger the mass or the larger the velocity, the larger the kinetic energy there is. So the bigger the object, the more kinetic energy it has that's moving, and then the faster something's moving, the more kinetic energy it has. The second kind we're talking about is potential energy. So potential energy is the energy an object has because of its position or its shape. So most of the time, potential energy is when something's sitting still. So it has the potential to move, and based on its position, but what is, depending on how likely it is to move, from its position is how much potential energy it has. So let's say a stretched rubber band, for example. If you stretch a rubber band, it's sitting still, but it has a large amount of potential energy, because as soon as it's allowed to move from that position, it's going to fly. It's going to have a lot of kinetic energy. Whereas a water bottle, sitting on my desk, it doesn't have a lot of potential energy. It does have potential energy, but not a whole lot, because it's going to take more to move that. It's not like you can just release it and it's going to fall over, fly across the room like a rubber band would. But objects that sit still have potential energy. Gravitational potential energy is essentially when you hold an object up, ready to drop, if it's held in the air, what is its potential energy of falling? So how much energy will it have as it falls? So the equation here is sort of equation number 2. Again, if you want to add these two slideshows, gravitational potential energy, you take weight times height. So what is the weight of the object and how high is it being held? So if you're holding a 10 Newton object 2 meters in the air, you're going to take 10 times 2 and you're going to get 20 joules. So how much energy does it have being held as it were to fall? So the larger the weight, or the higher it's being held, the greater your gravitational potential energy. Mechanical energy is our potential and our kinetic together. So it's technically in a different category, but it is the two that we just learned about put together. So it's the total energy of motion and of the position of the object. So sometimes mechanical energy is all potential energy, sometimes it's all kinetic, but sometimes it's both. So depending on if that object's moving or if it's sitting still, where is it's is going to determine how much it has of potential and kinetic within that mechanical. So equation number 3 already for this chapter is mechanical energy is potential energy plus kinetic energy. So one of our easy ones is just adding. So if you have an object that's a potential energy of 10 and a kinetic energy of 20, you add them together to get 10 plus 20 equals 30 joules. One thing with this is that there is a bit of a trade-off. So as potential energy increases, kinetic energy will decrease, and then vice versa. So as something starts to move, its potential energy goes down because it's now moving, but that means its kinetic energy goes up because it's moving. And then same thing, if something slows down to a stop, its potential energy goes back up, but its kinetic energy is going to go down because it's no longer moving. But no matter what, please, please, please remember that mechanical energy is going to stay constant. It's going to always, and I don't know if it's going to let me highlight something like this. I don't know why it's not letting me write, but mechanical energy is always going to stay the same. You're just going to change the amount of potential and kinetic energy that there is.